Hi students, welcome to Max Point of View. Today we are going to solve each and every numerical from the chapter Calorimetry Part A. So before solving these numericals, my suggestion is watch the concept video and theory solution, then come back to this part, then you will understand most of the things. So if you are trying to solve any numerical without knowing the concept, then it is very difficult. So go for the concept video, then go for the theory solution. You will get around 50 to 60% of the knowledge. Then if you come back to the numericals, you will understand everything in a easier way. So without wasting any time, we'll start with our first question. I have seen many students, they'll always struggle when it comes to numericals of calorimetry because they don't know the units and they don't know when to convert and when not to convert the unit. All those things I'm going to teach here before solving our first question. Listen, units and conversion. Listen, this C dash represents heat capacity. What is that? That is heat capacity. C dash is heat capacity. The unit of heat capacity is joules per Kelvin or joules per centigrade. See, in the exam they may confuse you with any one of these. See, most of the time we will learn this one only in the numericals, but you should know joules per Kelvin should be equal to joules per centigrade. How come? You will be thinking, how come Kelvin be equal to Celsius? We are not comparing directly. We are not comparing 200 degrees Celsius is equal to how much in Kelvin. No, that is not the comparison we are talking about. I am telling how if I increase one value in the centigrade, how much will increase in Kelvin? One value only. I'll show you how. Listen, 1 degree Celsius is equal to how much? 274 Kelvin. Correct. If I increase one value in centigrade, how much will increase in Kelvin? In Kelvin also it will be increased by 1. If I increase one more, in Kelvin also it is increased by one value only. So that in this way I am telling heat capacity has two units, joules per Kelvin or joules per centigrade. Most of the time we'll use this one. If in the exam they give this one also, you should not get confused. Both are same. Okay, now we'll go for the second one. This C dash represents what? Heat capacity. C represents specific heat capacity. See, if you don't know the concept, then these words are going to create a confusion in your mind. So my suggestion, go watch the concept video, then you will understand the difference between these two and how we got to know about all these formulas and all. Then it is very easy for you to solve the numericals. So C is specific heat capacity. Now the unit of specific heat capacity is joules per kg per Kelvin. Joules per kg per Kelvin, or I told you Kelvin, okay, Kelvin is not equal to Celsius, but this unit is equal to this one. Both are same. Joules per kg per Kelvin is equal to joules per kg per centigrade. Okay, you got to know the reason, right? Why we are telling both are equal? Because of this reason. Next, we need to understand how to convert from joules per kg per Kelvin to joules per gram per Kelvin. Listen, 4200 joules per kg per Kelvin is the specific heat capacity of water. Specific heat capacity of water. How do you convert this one into joules per gram per Kelvin? See, joules and Kelvin will not change. Only I am going to change from kg to gram. Answer will be 4.2 joules per kg per, sorry, this will be gram. Though joules per gram per Kelvin. And you will be wondering, from converting from kg to gram, it should be multiplied by 1000, right? But I have divided by 1000. Why? Because in here kg is not in numerator, it is in denominator. So if you convert kg, which is there in the denominator, to gram, you will divide it by 1000. So you need to understand only one thing: whenever you are converting joules per kg per Kelvin to joules per gram per Kelvin, you have to divide it by 1000, not multiply. Keep that in mind. Now listen again, joules per gram per Kelvin is equal to joules per gram per centigrade, only Kelvin to centigrade. So if they give you Kelvin or centigrade, don't worry about it. And listen, in the exam sometimes they may not specify whether it is heat capacity or specific heat capacity. You need to understand by the units. In heat capacity there is no kg, but in specific heat capacity there is per kg. So based on these two you can identify the units. See, in some question mass will be given in terms of kg, we will convert into gram. But in few questions we will use mass in terms of kg only. In few questions we will use mass in terms of grams. In few questions we will use mass in terms of kg. But your students will keep on getting confusion over that. Very simple, listen, that completely based on the specific heat capacity value. Okay, listen, if the specific heat capacity value in the question given in terms of kg, mass should be converted into kg. You got my point? If the specific heat capacity value is given in terms of kg, okay, you should convert whatever the mass is given, you should convert into kg. If it is given in kg, there is no need to convert. If the specific heat capacity value is given in terms of grams, then whatever the mass they have given, you have to convert into gram. That's it. So based on the specific heat capacity value, we are going to convert whether the mass should be in kg or gram. That we are going to decide for each and every question. So if you have this much knowledge, then there will be you are going to avoid a little bit of confusion. Now we are going to learn different formulas which we are going to use in all the numericals. Then we are going to start the numericals, because that will be easy for you. If you know all the formulas, all these conversion, you can skip and go to the numericals part directly. So before starting our first question, we need to understand the formulas and their terms. We have discussed all these things in the concept video also. For a numerical set, we'll discuss here also. Listen, Q. Q means, I know Q has many different names. Amount of heat energy required, amount of heat energy absorbed, amount of heat energy attained. All those meanings, for all those words, we have only one symbol Q. When it is related to heat energy, okay, heat capacity is different, heat energy is different. When it is related to heat energy, we have to use Q. Okay, C is nothing but specific heat capacity. Keep that in mind. C is nothing but specific heat capacity. And if you don't know what is specific heat capacity and what is heat capacity, that means you don't know the concept. Please watch that and come, you will understand everything. Okay, then this will be mass. Delta T. Delta T means change in temperature. See, T means temperature. Delta T means change in temperature. How much there is change in temperature? I'll give you an example. Initial temperature is 25. Final temperature is 15. What is the change in temperature? 10 degree Celsius. Difference in temperature, that is nothing but change in temperature, that is nothing but delta T. Next, C dash is nothing but heat capacity. We know Q and we know delta T. We know what is C. See, from the same formula, from this formula only we got this formula. Okay, so if you want C value, you move M and delta T that side. So C is equal to Q by M delta T. The same formula only. If you want to find specific heat capacity, you can directly use this formula. Then how C and C dash are related? Specific heat capacity and heat capacity are related. Heat capacity is equal to specific heat capacity into mass. You will get the value of heat capacity. Next, this one, see, this is based on the principle of calorimetry. This one I will explain using the question only. Don't worry about this. If you know, see, a few students will think only from this formula, if you know, you can solve any kind of questions. No, for 2 marks you will get these kind of questions, or else for 4 marks you can get these kind of questions. And this is also, if you understand, some extra calculations will be there, but if you understand the concept, you can aramse get 4 marks within 2 or 3 minutes. Our first question: by imparting heat to a body, its temperature rises by 15 degrees Celsius. What is the corresponding rise in temperature on the Kelvin scale? See, if you increase 15 degree Celsius of a body, temperature of a body, how much increase will be there in Kelvin? If you are thinking 273 plus 15, then it is completely wrong. Why? Because the answer is 15 only. This we have discussed in the beginning of this video only, during the units and conversions. Listen, I will explain here also. this one, 1 degree Celsius is equal to 274 Kelvin, 2 degree Celsius is equal to 275 Kelvin, 3 degree Celsius is equal to 276 Kelvin. How much I have increased from this point to this point? 1 degree Celsius. How much is increased from this point to this point? 1 Kelvin. That's it. So if 1 degree Celsius is increased, 1 Kelvin will increase. That is the meaning of this question. They are not asking you to convert from degree Celsius to Kelvin. They are asking if 15 degrees Celsius of temperature is increased in centigrade, how much that will corresponding results in Kelvin. 15 Kelvin only. Our second question, calculate the heat capacity of copper vessel of mass 150 gram if the specific heat capacity of copper is 410 joules per kg per Kelvin. First we'll write the given data, then we'll go for the solution. See, we need to find C dash, correct? This is what they are asking. Heat capacity. First to write the given data. See, in all the numericals, first if you write the given data, you will get an idea which formula to use. So write the given data. C dash we have to find. Then mass is given. Mass is given as 150 grams. Then specific heat capacity of copper is given. That is nothing but C. See, specific heat capacity of copper, water or aluminium, whatever they give, the symbol remains same, correct? We want specific heat capacity, that is nothing but 410 joules per kg per Kelvin. Okay, see, instead of Kelvin, if they gave you centigrade also, you are not going to convert into anything. This remains same. Kelvin, how much rise in Kelvin will be equal to how much rise in Celsius. So instead of Kelvin, if they give centigrade also, you are not going to convert into anything. This will be, you are going to use this one directly. Next, okay, this is the first sub question. First we'll solve it. This one, listen, we want heat capacity. What are the things given? Mass and specific heat capacity. See, to find heat capacity, this is one more formula, correct? Heat energy by change in temperature. Change in temperature also given, but heat energy is not there. So instead of going for this formula, we'll go for this formula. See, to find heat capacity, we have two formulas. In the same way, to find specific heat capacity, we have this formula and this formula. Anything is fine. Now to find specific heat capacity, we'll use this formula because these two are given here. Okay. But here, before substituting, you want to convert the mass into kg or will keep it in gram only? See, that depends upon specific heat capacity unit. If the specific heat capacity unit is in terms of grams, you don't have to convert this gram into kg. Now in this question, it is given in terms of kg, so mass should be converted in terms of kg. If specific heat capacity is in terms of grams, there is no need to convert. This is how in few questions we will not convert into kg, but in few questions we will convert into kg. So you have to be very careful with the unit of specific heat capacity. So anyhow, it is given in terms of kg, we have to convert this one into kg. This will be 0.15 kg. Okay, now we need to find C dash, that is nothing but Cm. What is C? That is 410. You don't have to write the unit because here also it is in kg and here also it is in kg. No need to worry about it. And mass, it is 0.15. The final answer will be 61.5. So what we are finding? C dash. What is the unit of C dash? This we have learnt in beginning of this video. The unit of C dash will be joules per Kelvin. That's it. Okay, this is the answer for A. We have one more sub question, B. How much heat energy will be required? How much heat energy will be required? That means we have to find Q. To increase the temperature of the vessel in part A from 25 degree Celsius to 35 degree. So delta T is equal to 35. You have to put the bigger value first. 35 minus 25 will give us to 10 degrees Celsius. Delta T is equal to 10 degree. Now we are going to find Q value. We have delta value, we have C, M, C dash, everything we have. To find Q. To find Q, you can go for this formula or this formula, anything is fine, whichever is easier for you. See here you can go for this formula only, anything in both the formulas you are going to get the same answer. Now Q is equal to Cm delta T. C is 410, M is 0.15, this one delta T is 10, so the answer will be 615. What we are finding? Q. Q is nothing but heat energy. The unit of heat energy will be joules. That's it. So first write the given data and respective formula, substitute in a proper unit. That is very much important. You need to know whether we have to convert into kg or gram. The completely based on specific heat capacity unit. If this is in terms of grams, no need to convert this gram. If this is in terms of kg, you have to convert into kg. If you don't convert also, you will get the answer. That will be completely wrong. If the answer is wrong, you will get the marks. That will be 0. So make sure before substituting the formula, make sure you are substituting the answer in a proper unit. And see again, writing the given data, substituting the respective formula and getting the answer. That's it. Our next question, a piece of iron of mass 2 kg has a heat capacity of 966 joules per Kelvin. Find the heat energy required to warm by its 15 degrees Celsius and its specific heat capacity in SI unit. Okay. First we'll write the given data. A piece of iron mass is equal to 2 kg and heat capacity is C dash, that is 966 joules per Kelvin, and heat energy required Q and temperature is given. See, if one temperature is given, that means that is the value of delta T. If two temperatures are given, you have to subtract it and get the answer. So here one temperature is given, that is nothing but delta T is 15 degrees Celsius is nothing but 15 Kelvin. This you know why we have writing like this. Next, and its specific heat capacity, okay, C, that too in SI unit. Okay, don't worry about whether it is SI or not. I will tell you, if it is in the form of kg, then that is the SI unit. That's it. We will find the answer at the end. Now, okay, first we need to find Q. To find Q, what are the things given? C dash, M and delta T. See, if C dash is given, and what is the relation between C dash and Q? See this formula. See, if they have given say a specific heat capacity, then go for this formula to find Q. If heat capacity is given, go for this formula to find Q. See here C dash is equal to Q by delta T. Now Q is equal to C dash into delta T. So the answer will be, see, first we'll substitute the values. Here what is C dash, that is 966 and delta T, that is 15. So once you multiply this to 14490, what we are finding? Q. Q is nothing but heat energy. The unit will be joules. That's it. This is the answer for first sub question, right? First sub question. Second sub question, we need to find specific heat capacity. See, to find specific heat capacity, we have many formulas. You can use you can make use of Q and mass and delta T also. See here, you can use this formula or you can use this formula. Anything which is easier for you. We'll go for this one only. See, C dash is equal to C into M. Specific heat capacity we want. Specific heat capacity is equal to C dash divided by M. Correct? See, this is the main formula. Correct? We want C. C is equal to C dash by M. What is C dash? That is given 966 divided by 2. Anything you divide by 2, that becomes half of it. So answer will be 483. And what we are finding? Specific heat capacity, and they want it in SI unit. If you want SI unit, what is the unit of mass? That is kg. So answer should be in terms of, the unit should be in terms of kg. That is nothing but joules per kg per Kelvin. That's it. If you write the answer in proper unit, what they are asking, then you will get full marks. Our next question, calculate the amount of heat energy required to raise the temperature of 100 gram of copper from 20 degree Celsius to 70 degree. And specific heat capacity of copper is also given, that is 390 joules per kg per Kelvin. Okay, first we'll write the given data. This is question number 4, and calculate the amount of heat energy that we need to find Q. And what are the values given? Mass is given 100 grams, and temperature delta T is also given, that is 70 degree minus 20 degree, that will be equal to 50 degree. Celsius is nothing but Kelvin. We can use it in any way. Next, specific heat capacity, C is given, that is 390 joules per kg per Kelvin. Okay, what we need to find? Q, correct. So what is the formula for Q? What are the given data? Mass is given, delta T is given, and C is given. Mass is given, delta T is there, and also C is there. We can use the first formula, C m delta T. So if you substitute the values there, and you will get the answer. Correct? Completely wrong. Why? Because the mass, the unit of specific heat capacity is joules per kg. So this is very much important. If this is given in terms of kg, mass should be in terms of kg. If this is in terms of gram, then mass should be in terms of gram. So now in this question it is given in terms of kg, so convert this one into kg, that is nothing but 0.1 kg. Now you substitute and get the proper answer. C is given as 390, mass is 0.1, and delta T is 50. So if you multiply all these things, we will get 1950. What we are finding? Q is nothing but heat energy. The unit of heat energy will be joules. That's it. Our next question, 1300 joules of heat energy is supplied to raise the temperature of 0.5 kg of lead from 20 degrees Celsius to 40 degree. Calculate the specific heat capacity of the lead. Okay, here listen, first we'll write the given data, then we'll understand what we need to find. So Q is given, this is question number 5, right? Okay, question number 5, Q is given, heat energy supplied, heat energy absorbed, heat energy attained, all those things, that is nothing but Q only. So that is 1300 joules, and mass is 0.5 kg, delta T is equal to 40 degree. First you have to write the bigger value, minus 20 degree, answer will be 20 degree. Celsius is nothing but 20 Kelvin. Then calculate the specific heat capacity. We need to find this one. See which formula we need to apply. If specific heat capacity, if you want to find, if heat capacity is given, we can go for this formula. So Q m delta T is all these values are given, we'll use this formula. So C is equal to Q by m delta T. Q is nothing but 1300, and mass is nothing but 0.5 into 20. If you substitute all these things properly, you will get the answer as 130. And mass was in terms of kg, right? The unit of specific heat capacity will also be in terms of kg. That's it. Joules per kg per Kelvin. If mass was in terms of grams, this would have been in terms of grams. So this is the final answer. Always try to keep the unit of specific heat capacity in SI unit only. So if they ask in SI unit also, we'll get the same answer. So everything mass should be in terms of kg. That's it. Our next question, find the time taken by 500 watt heater to raise the temperature of 50 kg of material of specific heat capacity 960 joules per kg per Kelvin from 18 degrees Celsius to 38 degrees Celsius, assuming that all the heat energy supplied by the heater is given to the material. That assumption part, whatever they are telling, that means there is no loss of energy. Whatever the energy I am giving, that is given to the material. So while giving the energy, there is no loss of energy. That is what they are telling. Now this question is completely different from whatever the numericals we have solved till now. Correct? It is related to power. So there is a relation between power and heat energy. See, this we already know. Electricity, in electricity chapter we have learnt all these things, but it is given in different forms of energy. Listen, this is question number 6. Correct? So first I'll write the given data, then we'll go for the formula which I told. Listen, watt is given. Watt is nothing but power, that is 500 watt. Next, the mass is given, that is 50 kg. It is already in terms of kg, no need to worry about it. And the specific heat capacity, that is 960. C is equal to 960 joules per kg per Kelvin. See, this is in kg. The specific heat capacity is also in terms of kg. No need to convert into anything. If this was in terms of grams, you need to convert this one into grams. Next, delta T. Delta T is 38 degree to 18 degree Celsius, that is nothing but 20 degree Kelvin, no degree for Kelvin, or 20 degree Celsius. Okay, these are the given data. We need to find what? Time taken. Time taken we need to find. Okay, see, I told you there is a relation between power and this one, heat energy. We have learnt energy is equal to, electrical energy is equal to power into time. This is what we have learned in electricity concept. Correct? This is electrical energy, and whatever we are talking about, that is heat energy. So all of them, that is whatever ends with energy, that formula remains same. So we can write Q is equal to P into T. We have the value of P. We can around find the value of Q. We need to find the value of T using the formula. Okay, so T is equal to Q by P. Correct? Q by P. Do we have the value of Q? No, but whatever the value we have to find Q, all the values are there. So Q, how do you can find the value of Q? Q is equal to Cm delta T. Cm delta T, everything is there. So instead of Q, we'll write Cm delta T by P. So what is C? C is nothing but 960, and M is nothing but 50 into delta T, that is nothing but 20, divided by power is 500. So once you calculate all these things, the answer will be 1920. The answer will be 1920. But what we are finding, time, this will be in terms of seconds. Correct? This will be in terms of seconds. If you want to convert into minutes divided by 60, the answer will be 32 minutes. So you can keep the answer in any value in terms of seconds or minutes. You will get full marks. I know in the textbook the final answer will be in 32 minutes, so you will be wondering whether I have to keep it in seconds or minutes. See, if they are asking specifically, they are asking keep the answer in terms of SI unit or minutes, then you have to worry about it. If they are not asking about anything, if it is in terms of seconds also, it is fine. Our next question, an electric heater of power 600 watt raises the temperature of 4 kg of liquid from 10 degrees Celsius to 15 degrees Celsius in 100 seconds. Calculate the heat capacity and specific heat capacity of the liquid. Okay, first we'll write the given data. This question is related to the previous question, that is question number 6. So now first we'll write the given data, then we'll find the answer using the formula. So electric heater of power is equal to 600 watt, then mass is equal to 4 kg, and delta T is equal to 15 degree minus 10 degree, that is 5 degrees Celsius or 5 Kelvin, anything is fine. Then time is also given 100 seconds. So we need to find C dash and C, both we have to find. Okay. To find C dash, see which are the formula to find C dash? C dash, specific heat capacity should be there and mass should be there. Mass is given, specific heat capacity is not given, so we cannot use this formula. We'll go for this formula. To find C dash, Q and delta T should be there. Delta T is here, delta T is here, and we need to find Q. To find Q, we have in previous question we have learnt Q is equal to P into T. That means heat energy is equal to power into time. Using that formula, we are going to find the value of Q, and we have delta T, will get the value of heat capacity. Using heat capacity and mass, we are going to find C. Okay. So to find Q, power into time. Power into time. Now, what is the power given? That is nothing but 600 into time, that is 100 seconds. So this will be 60000. What we are finding? Q. Q is nothing but, answer will be in terms of joules. Now using Q and delta T, aramse we can find heat capacity, right? So now the first question, our first question, we need to find C dash. So C dash is equal to Q by delta T. Just now we found Q by delta T. So Q is by delta T. Delta T, where is delta T? That is 5. So the answer will be 12000. And what we are finding? C dash, the unit will be joules per Kelvin. And second, we are going to find C, that is nothing but specific heat capacity. You can use this formula. See, you can use this formula or you can use this formula. Any formula, you will get the same answer. Now we'll use this formula only because we have only two terms. So C is equal to C dash by M. C dash, that is 12000 by M. What is M? That is 4 kg. So the answer will be 3000. And what we are finding? C. What is the unit of C? Joules per kg per Kelvin. That's it. Our next question. 0.5 kg of lemon squash at 30 degrees Celsius is placed in a refrigerator which can remove the heat at an average rate of 30 joules per second. How long will it take to cool down the lemon squash to 5 degrees Celsius? Specific heat capacity of squash is also given. See, don't worry about the question always. So whenever you get different kinds of questions, first write the given data, then you will understand the problem. And see, now this is question number 8, right? Mass is given as 0.5 kg, and in the question there are two temperatures, right? First it is 30 degrees Celsius, it has to change to 5 degrees Celsius. So delta T is equal to 30 degree minus 5 degree, that will be 25 degree Celsius. Next, what is given? That something is given that we don't know, that is 30 joules per second. What is this 30 joules per second? See, power value. Power, what is power? Power is equal to, see, power is equal to Q by T, correct? Q is equal to P into T. That is what we have learnt in few previous questions. So power is equal to, you just move this time this side. So Q by T. What is the unit of Q? That is joules. What is the unit of time? That is seconds. That is nothing but joules per second. If joules per second is given, that is nothing but power is given. This you should know. Okay, this is very much important. Next, what are the things given? How long will it take? No, we have to find the time. And what is the another thing? C is given. C is equal to 4200 joules per kg per Kelvin. Okay, these are the given data. First we need to understand what should be found. Okay, listen, we need to find time using power and Q, correct? See, to find this is the main formula we used in a previous question, right? We need to find time. So time is equal to Q by P. We have the value of P. Do we have the value of Q? No, right? So substitute all the values. Q is also not given. To find Q, what is required? See, to find Q, specific heat capacity is given, mass is given, delta T is given. So instead of Q, we'll write delta T by P. C is nothing but 4200, mass is nothing but 0.5, and delta T is nothing but 25 divided by P is nothing but 30. So once you calculate all these things, the answer will be 1750. What we are finding? Time, right? So answer will be in terms of seconds. If you want to convert into minutes, it will be 29 minutes 10 seconds. That's it. Our next question: the mass of 50 gram of a certain metal at 150 degrees Celsius is immersed in 100 grams of water at 11 degrees Celsius. Listen, this question is completely different from previous questions. Why? Because till question number 8 we were not immersing any one object in one more object, correct? See, here we have two objects. All 8 questions were related to only one object. When two objects come in picture, we are going to use this formula. Okay, you got my point? When I told you this formula will be discussed when the question comes, correct? When one object is immersed in one more object, then we are going to use these kind of formulas. One object may be same object, like hot water in a cold water, all those things. Hot water is considered as one object, cold water is considered as one more object. When one object is immersed or poured in another object, then we are going to use this formula. This method is called as method of mixtures or principle of calorimetry. Okay, principle of calorimetry is nothing but when you immersed or pour one object into one more object. Okay, here we are talking about a metal, okay, is immersed in water. A metal is immersed in water. So one object is immersed in one more object. Then in these kind of questions we are going to talk about this formula. In all the rest of the questions which we have solved till now, question number 8, till question number 8, we were talking about only one object. We were not immersing or pouring it in another object. So we did not use this formula. Whenever an object is immersed in one more object, then we are going to use this formula. That principle is nothing but principle of method of mixture or principle of calorimetry. Now we'll write the given data, then we'll go for the formula, and I'll teach you how to substitute and how to calculate also. Few students will use around one complete page to calculate these kind of questions. I'll teach you how to solve these questions within 4 to 6 steps. That's it. Listen, first we'll write the given data. The mass, there are two objects, right? So first object we'll consider as M1, and there are two temperature, right? First temperature will be T1 and second temperature will be T2. Like M2 will be the mass of the second object. So the mass of the first object, mass of 50 grams of certain metal. So this is question number 9. M1 is 50 grams and mass of water is also given. M2 is equal to 100 grams. Next, T1, T2 is given. T1 is equal to 150 degrees Celsius and T2 is equal to 11 degree Celsius. The final temperature is also given. We don't know what is final temperature in the formula, right? I'll teach you, don't worry. That is 20 degree Celsius. See, T1 is nothing but temperature of first object, that is metal. T2 is nothing but temperature of the second object, that is nothing but water. And T is nothing but final temperature, that is given in the question directly. Then calculate the specific heat capacity of metal. So we have specific heat capacity of water, and see, there are two C's, right? C1 and C2. First C will assume it as specific heat capacity of metal. Why? Because mass is M1 we have taken it as mass of metal, correct? So C1 we can assume it as Cm, that is what we have to find, that we can assume it as specific heat capacity of metal, and C2 we can assume it as CW, specific heat capacity of water. This is the first object, this is the second object. So that is given 4.2 joules per gram per Kelvin. So see, this unit is very much important. If this is in terms of gram, these all the masses should be in terms of grams only. If this is in terms of kg, you have to convert all the masses into kg, or else you can leave these grams as it is and you can convert, if kg is given, convert this one into grams. If you want to convert joules per kg per Kelvin to joules per gram per Kelvin, you just have to divide it by 1000 if kg is given. Okay, now gram is given. This one, the conversion we have learnt in the beginning of this session only. So if this gram is given, all the masses should be in terms of gram. If this is in terms of kg, we need to convert all the masses in terms of kg. Now all these are the given data. I mean, now we'll apply the formula. See, first thing you need to write is principle of calorimetry. Okay, see, I told you, right, this kind of questions few students first will solve first half and second half, then they'll substitute. That will take one complete page. Instead, we'll go with 4 to 5 lines only. Principle of calorimetry will tell us heat energy lost is equal to heat energy gain. See, first you have to write this statement. See, this given data is for our reference and these two are compulsory. Principle of calorimetry, or else you can write it as principle of method of mixture. Okay, both are same. This is easy to remember. So principle of calorimetry is nothing but heat energy lost is equal to heat energy gain. Which is losing heat energy here? The temperature of metal 1, mass 1 is 150, correct? So this is losing this is immersed in water. The temperature, for the final temperature of the metal is 20 degrees. So which is losing? This one. So heat energy lost will be equal to heat energy gain. This one is referred to the metal. This one, we are immersing the metal into the water. So the water is going to gain some temperature because the temperature of the metal is 150 and the temperature of water is just 11 degree. So the water is going to get the heat energy, right? So it is gaining heat energy. Whatever we are going to write on the left side, that is related to metal, on the right side it is related to water. So M1. Next, here according to this one we have to write C1. Here we know we are definitely talking about, see, this complete thing is related to metal, that complete thing is related to water. So C1 represents metal. So instead of writing C1, we can write it as Cm. Okay, that is what we are going to find into T1. What is T1? 150 degree. Sorry, we have to write the formula first. T1 minus T is equal to M2. C2 is nothing but specific heat capacity of water into T minus T2. Now we substitute and get the answer. See, M1 is nothing but 50. Cm we don't know. T1, that is 150 minus T is 20. M2 is nothing but 100. Cw is nothing but 4.2 and T is nothing but 20 minus T1, that is nothing but 11. Sorry, T2 minus T2, that is nothing but 11. We need to find Cm, right? Move all these things that side. Okay, now this will be Cm into 50 into 150 minus 20, that is 130, is equal to 100 into 4.2 into 20 minus 11, that is 9. So what we need to find? Cm, correct? Cm is equal to 100 into 4.2 into 9 divided by 50 into 130. So the final answer will be, if you calculate it properly, the final answer will be 0.582. So what we are finding? Specific heat capacity, correct, of metal, and we have used grams, right? So the specific heat capacity will be joules per gram per Kelvin. That's it. See, in 4 to 5 lines only we'll get the proper answer. You don't have to go for the, see, few students I have seen in the textbook also they have given the same method, but the final answer will be same, and you can, if you use this for method also, you'll get the full marks. This method also is given in the textbook. First they'll solve this one separately, then they'll solve this one separately, then they are going to equate, then going to get the final answer. Instead of doing that, you can go for this method only. You will get the answer in 4 to 5 lines. So first thing is you need to write the principle of calorimetry. That means heat energy lost is equal to heat energy gain. So heat energy lost, which is going to lose the energy, the metal which has 150 degrees Celsius, and when you immerse this one into water, the temperature is reduced to 20 degrees. So this has lost and water is going to gain. So whatever you are writing on the LHS, that will be related to metal, and RHS will be related to water. Substitute and make sure you are not doing any silly mistakes here. And finally, final answer, if that after the decimal, if first 2 digits are correct, you will get full marks. You don't have to worry about this one. If the third one, you don't have to write it. If you write and if it is wrong also, instead of getting 0.582, if you get 0.585 also, you will get full marks, but because we are focusing only on the first 2 digits after the decimal point. This is what they'll instruct us while correcting your papers in the board exam. So we will be given a key answers. In that they'll mention everything. So based on that only we are going to correct. After the decimal point, first 2 digits are enough. Our next question: 45 gram of water at 50 degrees Celsius in a beaker is cooled when 50 gram of copper at 18 degrees Celsius is added in it. The contents are stilled till a final constant temperature is reached. Calculate the final temperature. The specific heat capacity of copper is given and specific heat capacity of water is given. State the assumption used. So here they are asking for the assumption. Don't worry about it. I am going to teach that. First we'll write the given data. So 45 gram of water. So in the previous question we took metal as object 1, correct, and water as object 2. Why? Because metal was losing the energy. The temperature of metal was greater than the temperature of water. Here which is greater? The temperature of water is greater and temperature of copper is less. So which has a greater temperature, you write it on the LHS, and that we assume it as object 1. Which has the lesser temperature, we'll write it as object 2, just to avoid the confusion. You can take any one, but in the exam I don't want you to do the mistakes. So what we are going to do, which object has more temperature, we'll write it on the LHS. Which object has a less temperature, we'll write it on the RHS. Now here water has 50 degrees Celsius and copper has 18 degrees Celsius. So water we are going to take it as object 1. So object 1, mass 1 is equal to 45 grams and it has temperature, that is nothing but T1, 50 degrees Celsius, and specific heat capacity of water is given, that is 4.2, that is nothing but CW, right? Write it as CW just to avoid the confusion. CW, specific heat capacity of water is given, that is 4.2 joules per gram per Kelvin. If this is given in terms of grams, the mass should be in terms of grams. If it is not in terms of grams, you have to convert into kg. Next, we'll talk about copper. Mass 2, that is also 50 grams, and T2, that is 18 degrees Celsius, and specific heat capacity of copper, that is also given, that is 0.39 joules per gram per Kelvin. Okay, we need to find the final temperature. So final temperature is our question. Okay, first we'll apply the formula. See, before applying the formula, what I thought you to write, principle of calorimetry. Principle of calorimetry. Okay, this is nothing but heat energy lost is equal to heat energy gain. They are asking for the assumption, right? This is the assumption we are assuming. See, heat energy loss is equal to heat energy gain. This is the assumption they are asking. If they ask or they are not asking, you write this one. Okay, in the bracket you can write assumption. Okay, then they will understand, whoever correcting your paper, they will understand this is the assumption you are making. So we'll write the formula. Here mass 1 is nothing but the water, and C1 is nothing but specific heat capacity of water. Then T1 minus T is equal to mass 2 is equal to Cc T minus T2. Okay, now what we are going to find? Final temperature. So that is not given, remaining everything is given, correct? See, in the previous question they were asking for the specific heat capacity which is outside the bracket, so we substituted the values and got the answer in a easier way. But here whatever the answer we are going to find, that is inside the bracket. So before substituting the values, we will get the final value, final formula, then we can substitute and get the answer. Listen, okay, first we'll multiply these two with this one and these two with this one. So this becomes M1 CW T1 minus M1 CW T. Correct? If you multiply these two with these two, we'll get this one. Again we have whatever we have to find, that is inside the bracket. That's why we are not substituting the values now. So multiply these two with these two, M2 CC minus M2 Cc T2. Now we have here we have T and here we have T, correct? So we'll move, this is minus, we'll move this one that side and we'll move this minus term this side, so that the final temperature, the complete final temperature terms will be on one side and others will be on the other side. So this becomes M1 CW T1. If I move this one here, this becomes plus M2 C2 T2, and here this one M2 CC T, this I'm going to move this side, this becomes plus M1 CW T, correct? So here in Haramsa we can take the common, correct? So this is nothing but T is equal to M2 CC plus M1 CW, and here we have M1 CW T1 plus M2 C2 T2, correct? Now here see, if they ask, these kind of questions will be rarely asked because this requires more than 10 steps, right? So for 10 steps they cannot extend the marks for more than 4 marks. The maximum marks in physics for a question is 4 marks. They cannot extend the questions. So these kind of questions are really rare, but you need to know how to solve it. Listen, so now we need to find T, right? If we move, we'll going to move this one this side, so multiplication will become division. I'm going to move this one here. So this will be M2 CC plus M1 CW is equal to T. Now if you substitute all these values, whatever we have written in given data, and substitute, we'll get the answer as 47 degrees Celsius. Definitely you will get. See, this step is very much important till here. See, very much important is the steps. Now you substitute the answers, you will get the answer as 47 degree definitely if you do the calculations properly. Our next question, 200 gram of hot water at 80 degrees Celsius is added to 300 gram of cold water at 10 degrees Celsius, neglecting the heat taken by the container. That means assumption. The previous question we know, right? Assumption, that is what they are saying. Heat energy lost is equal to heat energy gain. That is what they are telling in different way. We have to neglect the heat taken by the container. Calculate the final temperature of the mixture of water. Specific heat capacity of water is 4200 grams per kg per Kelvin. First we'll write the given data, then we'll go for the solution. So this is question number 11, and mass, see here, which has high temperature, mass of hot water, so that we are going to write it on the left side, that we assume it as object 1. Okay, which has high temperature, that we'll assume it as object 1 and we'll write it as on the left hand side. So mass 1 is equal to 200 grams and temperature T1 is equal to 80 degrees Celsius and Cw is equal to 4200 joules per kg per Kelvin. Don't worry about this one. For this question you will understand why while writing the answer. Okay, now M2, that is cold water, that is nothing but how much? 300 grams. Temperature T2 is equal to 10 degrees Celsius and Cw, we are talking about the water again, right? For water, this one finally they are going to mix, the specific heat capacity will be same, correct? So Cw is equal to 4200 joules per kg per Kelvin. Okay, now first what we have to write? Principle of calorimetry. Principle of calorimetry is equal to, here we have to find final temperature, keep that in mind, heat energy lost is equal to heat energy gain. So whatever they tell, write the assumption or neglecting the heat taken by the container, don't worry about it. You follow this method, you are writing everything. Okay, don't worry about it. So which is losing energy? That is mass 1, that is object 1, hot water. So I will write the formula M1 Cw T1 minus T is equal to M2 Cw T minus T2. In both the sides we have Cw common, so we can neglect it from the formula. Now again we have to get the value which is inside the bracket. So before substituting the values, we'll get the final formula and get the answer. We are going to multiply this one with both the terms, M1 T1 minus M1 into T is equal to M2 into T minus M2 into T2. In these two terms we have final temperature. We'll move on to one side. I'll move this one this side and I'll move this one this side. So the final temperature will be on one side, remaining things will be on the right side. So M1 T1, I'll move this one this side, minus becomes plus M2 T2. I'll write this one as it is, M2 T minus becomes plus M1 T. So this will remain same, and here I'm going to take T as common, so this becomes M2 plus M1. Here M1, this remains everything same. So now to find the value of T, M1 T1, this I'll write it as it is, M2 T2. I'll move these terms this side, so this becomes M2 plus M1. So you whatever all these values are here only. Once you substitute, and the final answer will be T is equal to 38 degrees Celsius. That's it. So this is exactly similar to previous question. In previous question, one object was immersed in water, correct? But here we are both talking about, both water itself. So hot water and cold water, in both the cases this one specific heat capacity will be same, so both will get cancels. Then get the formula, substitute the answer directly, or else you can do one thing, instead of doing all these things, you can by heart the final formula. In previous question one formula was there, and in this question one formula is there. So this question is related to the previous question. In previous question, this one specific heat capacity of different metals, different object was different. Here it is same, that's why we are not using it. So see, if you can do this one in the main exam, that is fine, or else you can by heart the formula. But by hearting the formula, there is one problem. If you do one silly mistakes in the exam, everything will be wrong, and you are going to get only 1 mark for this assumption. That's it. Our next question: the temperature of 600 gram of cold water rises by 15 degrees Celsius when 300 gram of hot water at 50 degrees Celsius is added. What is the initial temperature of cold water? I know this question will definitely confuse you a little. but if you can understand the sentences, aramse we can write that. First we'll write the given data, then we'll understand. So which one we are going to assume it as object 1, which is hot, the hot water, right? That we are going to assume it as object 1. Keep that in mind always. So which is hotter, which temperature is more, that we are going to assume it as object 1. So hot water of 300 grams. So this is question number 12. Mass 1 is equal to 300 grams and temperature 1 is equal to, so temperature of this one 50 degree Celsius, and we know both we are talking about water only, so we don't require specific heat capacity of water, because hot water, cold water, they are going to cancel. That is what we have learned in previous question. So then object 2 of mass 600 grams. Okay, and T2 is not given, keep that in mind. That is what they are asking. What is the initial temperature of the cold water? That is what we have to find. And final temperature is also not given. Final temperature also not given. Not given. Then what is that 15 degree Celsius? What is this 15 degree Celsius? See, once you pour that hot water into cold water, the temperature of cold water rises by 15 degree. That means, so on this we are going to assume it as cold water, right? Because this one object 1 we assume it as hot water, correct? Because this object has high temperature, and this will be cold water, correct? This is related to cold water. When they are telling the temperature of a cold water rises by 15 degrees Celsius, that means the value of T minus T2. 15 degrees Celsius is nothing but T minus T2. This is very much important. So temperature of water rises, cold water rises by 15 degrees Celsius. This 15 degrees Celsius is nothing but T minus T2. So using all these data, we are going to find the T2. Okay, this T2 value, I'll show you how. First I'll write the method. Again, I'm not going to write that assumption and all. Principle of calorimetry. In the next step, heat energy lost is equal to heat energy gain. That we have written in for 3 questions. Now onwards you are going to write. I'm going to write the formula directly. If you don't write it, 1 mark you are going to lose. Okay, that is the main assumption we have to do. Okay, then M1. So both the sides we are talking about water, right? First I'll write it, then I will cancel. M2 CW T minus T2. So both the sides CW is cancelled. Now we'll substitute the values. M1 that is 300 grams into T1 that is 50. Final temperature is not given. Okay, that is what we are going to find. Using that we are going to find this one. M2 that is 600. Okay, so this one T minus T2, that is what we found, that is 15 degree. That I explained why we have taken this as 15 degree. Now instead of multiplying these two, I'll send this one that side initially. So this side 50 minus T is equal to 600. See, this multiplication will become division, correct? See, this is multiplication, right? If you send that side, it will become division. 2 zeros, 2 zeros, 3 ones are 3 twos are. So this side 30 is left, and this side 50 minus T. If you send this T that side, or you can move anyone is fine. I'll move this T because this T has minus, right? I'll move this one this side, 30 this side, and T will be equal to 20 degree Celsius. T will be equal to 20 degrees Celsius. What is this T? This is the final temperature. Do we know the value of T2? No, right? So here substitute the final value here. So to find T2, see, to find T2, I'll move this T2 that side and 15 degree this side, because this T2 has minus, correct? I'll move this one this side. To find the T2 you can use any method. So I'll move this T2 that side and 15 degree this side, because T I know and 15 degree I know. So T2 is equal to T minus that 15 degree. So that is 20 minus 15 degree. T2 is equal to 5 degree Celsius. That's it. See, if you know the concept in In previous questions only we are using all these method. Whenever we talk about two waters, two different hot water and cold water, CW will get cancels. Keep that in mind. Our last question, 1 kg of water is contained in 1.25 kilowatt kettle. Calculate the time taken for the temperature of water to rise from 25 degrees Celsius to its boiling point, that is 100 degrees Celsius. Specific heat capacity of water is given, that is 4.2 joules per grams per Kelvin. First we'll write the given data and we'll go for this kind of exact problem we have solved earlier, but again we are going to solve it. This is question number 13. Mass is given, that as 1 kg. Then power is given, that is 1.25 kilowatt. So this is nothing but 1250 watt. It should not be in kilowatt, keep that in mind. Calculate the time taken. So we are going to find the time taken. And what are the other things given? Temperature, two temperatures are given, so subtract it. So delta T is equal to 100 minus 25, that is 75 degree Celsius or 75 Kelvin, anything is fine. And CW is given, that is nothing but 4.2 joules per gram per Kelvin, correct? So we need to find capital T. Using power and energy we can aram se find it. What is the main formula we used it? Q is equal to P into T. We want T, so it will be Q by P. These kind of questions we have solved earlier. Then Q value is not given in the question, but to find Q, what is the main formula? Q is equal to Cm delta T. CW or C, anything is fine. Cm delta T, everything is there. We can aram se substitute and get the answer. Cm delta T by P, correct? So all these values if you substitute, you will get the answer, correct? Completely wrong. Why? Because very important thing. What about the unit of mass? Mass is given in terms of kg, but specific heat capacity is given in terms of grams. So if the specific heat capacity is given in terms of grams, you have to convert this mass into grams. Then here instead of multiplying 1, you have to take it as 1000. This is in grams, we have to convert this into grams. If this is in kg, if the kg is there, then it is fine. Now it is in grams, we have to convert this into grams. C, that is nothing but 4.2, mass 1000, and time delta T is equal to 75. Power is equal to 1250. See, if you calculate it properly, the answer will be 252 seconds. If you want to convert this one into seconds, that will be 4 minutes 12 seconds. That's it. So now we have completed all the numericals from the calorimetry part A. So next we are going to learn the concept and theory solution of part B. After that, go for numericals, you will understand everything. Once we complete all these videos, we are going to create videos based on question papers. Not like from 2017, we are not going to discuss questions. No, it's not like that. We are going to select this, what is this chapter? Calorimetry. From calorimetry, okay, since 2017 till last year, what are the questions they have asked? Like that we are going to do the videos. So not only you are getting the answers for textbook question, you will understand how these questions are completely different from the board question paper. Then you will get complete knowledge. Thank you.